All right, welcome. This is mostly intended to be for any of you who are not as familiar with JavaScript yet or HTML programming. If you maybe got a background in Java or C++ or something more about executable programming, then I'm just going to do a little intro here, how to get you up to speed on working with web programming and maybe a few interesting differences between JavaScript and Java or C++ or some other language that you might be familiar with. They have some syntactical similarity, but that's about it. And it's nice that they have some syntactical similarity. You know, your for loops and if loops and so on, or if thens are going to look similar. They're going to use scoping with curly braces and so on. So some of it's going to look familiar, but a lot of what's actually going on underneath is actually a lot different. And so I'll fill in a few of those details. Now, if you haven't worked with web programming before, then what you're going to need is you're going to need to start with an HTML file. And I've actually just got a very simple HTML file here. This one, and usually your HTML file is called index.html. Now, if you want, you can just create one your own, or usually what I do is I cut and paste one that I've got before. I do a lot of web programming, but I don't do a lot of HTML programming. I don't work with the HTML a lot. Often I just have one element in here like I have here, a canvas element, which is what we're going to be building our game in the upcoming videos. So for now, I'm not going to worry too much about the other pieces of the HTML, and really you need to know very little HTML. The body is where you have most of what's going on. The head is where you've got a little bit of other things. One of them is you can give a title, and this is, I just called this one Game Project Shell because it's kind of empty. It doesn't have anything in it at the moment. And then also in your head, you can load in your JavaScript files, which is your program, and this is how basically your web browser is going to run your JavaScript program. And so I'll just go through a sort of step-by-step process here. What I have over here, I've got my web browser, and I've loaded up this index.html by just double-clicking on it. Now, you can't actually see my browser bar here, but in my browser bar, it has a local file loaded in. So if you go into your own directory, you find an HTML file in there, you double click it, it will load it as though you were going to a web page, but it's just loading it and reading it from your own directory, your own computer, instead of going on the internet to access it. And usually when you're developing a web page, this is how you would do it first. Before you make your web page live and test it there, you test it on your own machine to make sure it works there. So that's the first step. Maybe you've built an HTML file, or maybe you downloaded it and copied mine, in which case you just double click it and open it, and you should get a little window that looks like this as well. Now, as I mentioned in my last video, if we want to, we can just do a quick F5 on that window, and that will reload it. Of course, nothing happens here. I just have a blue square. My canvas has a blue square, and then I have this JavaScript that we're loading in. Okay, now what happens when you load something into your browser, whether it be a web page or one local on your hard drive like this? The first thing it does is it loads the HTML file in. And the HTML file is this file here, which includes all of this text. Now, it reads it in. Everything that we load in for the most part on the web is going to be text data. If it's not something like an image or a video, then it's going to be text data. And so what the browser does is it reads through this text here, and it gets to each line. And when it gets to this line, the line that says script, it says, oh, I need to download an additional file here. And what is that file? It's going to be a JavaScript file, and it's called hello.js. So when your browser, when you double click the index.html, it loaded the first file, this one, but this gives a signal to your browser to say, hey, go get another file. Now, if this was loaded on your own machine locally, then this hello.js is saying, go look in the same folder that this index.html is and try and find something called hello.js. So hopefully it's there. If it's not there, it'll throw an error. It'll say failed to load. Okay. Otherwise, we could, if you were on the web, it would look in the same folder that it had loaded the index.html from. So maybe you're in some web address, www.something/index.html, then this would say, look in the same directory. And of course, you probably are familiar with how you can navigate directories a bit. If we wanted to have, subdirectories, sometimes we put this in a script directory. We might have this as ./script/ hello.js, something like that. Okay, so this is just telling us to load that file. And the browser will now go fetch that file and load it as well, because presumably this web page that the browser is loading needs that file. That file is going to help it do something on that page. Now, in addition, usually we're going to have a bigger body here where there might be some text. We might type something, a paragraph or two, and then we might put an image or something else here. In my case, I only have one, the canvas, but in the normal loading of an index.html, it will get to these lines now, and it will start maybe loading some more things as well. Maybe it sees here an image tag that says, it's a picture of your face or something, and it says, okay, now I need to go get picture.jpg or whatever it is. And then every time it hits an image tag or a video tag or an audio tag or something like that, it might trigger another download of another file. And so one important feature of this that we're going to have to take into consideration in at least the next couple videos is that this happens asynchronously. And what that means is each download is triggered as we encounter it in the HTML file that we're reading. So maybe we will get to the script file first, we will start downloading it, then we might, usually you have multiple script files, so we might trigger off 5 or 6 downloads there, and then we might get to a couple images. The order that they arrive in is the asynchronous part. We trigger them in this fixed order. As we read them, we start each download. But when they arrive depends on a lot of factors that we might not even know about, and some factors that we might have no control over. So some we might know about, like the size of the image. So a bigger image is probably going to take longer to download than a smaller one. Same thing with our script files, larger ones versus smaller ones. Now script files are text files, so they are typically smaller than image files. So you might expect your scripts to download before your images to download, which will probably hit there before the videos download, but still, these are just rules of thumb, things we might expect. They might come out of order. And so as a result, if you can remember back to the old web, the good old days of the web, the new web programmers are a little bit more clever than this, but in the old web, you would get a web page and the first thing that would appear would be like some text, and you'd have a bunch of broken images. And slowly the images would sort of fill in one at a time, and that's because the asynchronous downloads would finish, and as they would finish, your browser would display the new file. Now, of course, the modern browsers, usually what you'll see now is you'll see nothing. You'll see a little loading ... or something, and the browser is sort of secretly waiting. It's saying, okay, I'm going to download all the files, and as soon as they all get there, then boom, everything arrives. And that's just because, well, designers think, hey, it looks better when you have everything finished than seeing, pieces pop up and seeing sort of all the working pieces behind the scenes. So that is a side effect, or that is an artifact of the asynchronous nature of the web in general. And actually, a lot of different programming is asynchronous, but we're gonna use the asynchronous nature, and we're gonna have to exploit it in our creation of our simulations and our games. Okay, so this first little bit here was just to say what happens when we load the HTML, and keeping in mind, I'm not going to focus on the HTML very much. Almost all the HTML we're going to look at is going to be this, okay? The only difference, if you're going to be following along with me and you're going to want to make changes, you might want to change some of the details here. In fact, I think my Mario is set to some slightly different parameters, 768 by 768. And we could change a few things, background style and so on, but I'm just going to do that. Let's maybe see what happens if I go back out to now my page here and do an F5. Oh, it got a little bit smaller. Okay, so again, the other thing you might want to do is you're going to take a cut and a paste of this line here, at least that's how I do it, and maybe load different JavaScript files. I'll just quickly jump over here to my other index.html. This is for my Super Mario Brothers, and you can see there's a lot more going on here, but in terms of my actual body, there's the canvas, there's one line that says Super Mario Brother, and then there's another line here. This is a little debug checkbox that I've created, but otherwise the only main changes I've made to this HTML from the other one is I just put a whole bunch of other scripts in there, okay? And that's just a bunch more JavaScript. So we don't want to start with all that because that's a bunch. So I wanted to start with something simpler. So I said, let's look at this hello.js, which is what I've got right here. Okay, now one thing we're going to notice is that the web page that I've got here, it doesn't do anything, as I mentioned. It's just a big blue square at the moment. But that's because all the JavaScript that I have is not actually doing anything to the web page itself. It's just in the background doing something. It's calculating something in the background and not displaying it on the page in any way. In fact, where it is displaying it is actually in the console.log. So let's see if we can open that up. Okay, so here we've got the dev tools up again. Remember, we open these by doing a Control-Shift-I, or right-click inspect element, or right-click inspect on the web page, and that will load up your, usually it's just a window with a bunch of tools in it, and in particular, though, I think I mentioned in the last video, the tools that I usually look, the source. So here we can go check what sources did we load. Here's that here's that exact same file we're just looking at over here as well, and then we also have the console, which is what I mentioned here. So let's just maybe start by looking at the code. And we can see here that the first thing that I want to mention about JavaScript that's different from at least C type languages in Java that you might be familiar with is that we have weak typing in JavaScript. Now what that means is there's no types. That's not exactly what that means is you don't have to worry about your type. There are types, there are numbers, and there are strings and other things in there, but there are no reserved words, int, string, and so on. So we can see here in this code here, I'm using the word int as a variable name because it's not a reserved word. And if I want to declare a variable in JavaScript, at least in vanilla, the original JavaScript, you would use a var. And in a second here, I'll talk a little bit more about that. So var just stands for variable. As you can see here, I'm defining 4 different variables, int, double char, and string, and they all have technically different types, but they are all defined in the same way. Okay, now when I say they all technically have different types, I mean they function differently. I can take my int and do integer math on it in a way that I can't do that with my string. But they also are sort of all loosely interchangeable, and the language of interchanging, at least for JavaScript, are strings. So for instance, right now I could take my int and I could plus it to my string, and in fact I do that right here. I take a string and I plus it to int, and as we'll see, as we see that pops out here, we get int 42. So what it's done is it's taking this number, which is technically a number when we've stated it up here, and translated it into a string so we can output it here. Okay, so the default is going to be strings, and that means when we do a plus like this, the default here is going to be string concatenation. So we're going to concatenate these two together. And the same thing is happening down here below. The next number I have here is math.py, and math.py we can see here it's a double. It's got a decimal expression here. I've just pulled that out of the math library, and when I output it again here, it converts it to a string before it outputs it. Okay. Likewise, we did an A, we did a hello world, and I've output those as well. Okay, so the output that we're getting here are generated by these lines here. All right, now one thing that we're going to notice here is that these lines are using something called the console.log. Well, here we are over on the console, and so these console.log messages are, you know, your print line messages or your cout messages or whatever you're used to doing in whatever language that that you program in. This is just a way to basically send yourself some messages while you're writing your code for debugging purposes or any other purposes. Okay. Now, What else do we have in JavaScript? Well, we do have these sort of base types, if you will, these sort of derivative data types, and then up here we have maybe our containers. And your typical way of making a container is to either build a list-like object, like an array, or maybe a structure like an object. And so in JavaScript, there's sort of a default way of doing both of these, which is if you want a sort of a listy kind of thing, you'll build these square brackets. And if you want to declare a default object, you'll use these sort of curly braces. Now what these two lines actually do is create empty versions of this. This is an empty array and an empty object, which are, as you can imagine, kind of not very useful. An empty array a little bit more useful because we can use the dot push, as you can see just down below here, the dot push to add things into the array. But the object, well, we usually will build objects in different ways. We don't make them empty like this and then stick things into them. We could do that. JavaScript allows us to do that, but we probably don't. We probably it's probably not the best coding style to build objects up in that way. And you probably want to build objects either if they're just structures. Remember, by structure I mean an object without any methods attached to it, just the data. If you do that, sometimes we do them on the fly like this, and I'll show you a few examples of when I might do that. But then also, usually if we're going to make an object that does have methods attached to it and so on, we'll create that in the more familiar way that you would in other languages by creating a class object and then newing it, making an instance, which is, again, a little bit of syntactic sugar in JavaScript to make things feel comfortable like Java or C++, even though underneath the hood something else is going on. But for our purposes, we can treat it as though it's functioning in pretty standard object-oriented programming way. But I'll point out any cases where that might not work. Now here we have our standard way of building a function in JavaScript. Okay. Again, a couple things to highlight. Notice no type on the parameter, and that's because, again, there's weak typing. You don't have to tell the type. There are ways with various other kinds of scripting that are scripting languages that are placed on top of JavaScript to enforce types or type checking if you want to make sure. I find, at least in the code that I build, it's at least lightweight enough and small enough that I don't have problems where I have to enforce parameter types. So I actually enjoy this. So I think one thing that you'll find, and this is this feature of being weakly typed, that most programmers that come to JavaScript from, say, a Java or a C++ language are going to either love JavaScript or they're going to hate JavaScript. And I happen to be one that loved it. I happen to really dislike Java and C++ for how verbose they are, how much typing you have to do to get any one thing done. Whereas in JavaScript, you can get away with a lot of things. So one of the places where you're saving yourself keystrokes all over the place is, instead of having to write list of something, blah, 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 array, you just type var array. Or in your parameter, again, repeating your list of something, you can just put here nothing. You just put nothing. So it saves a lot of keystrokes, but then it enforces, this is where the hate it comes. So if you're like me, you love this, but if you're not like me, you maybe hate this, because then you're going to say, well, how do I remember? Exactly, how do you remember? And that's why I said a lot of the code that I write is lightweight enough that my brain can keep track of it so I don't run into the problem. So it doesn't cause me the problem. But if that is something that you or your team, maybe you're working in a team, then you're going to want to maybe develop some coding practices to get around some of these pitfalls of JavaScript. So again, maybe I'll put this into context. JavaScript, in Java, there are lots and lots of rules that if you break, it just makes an error and then your code doesn't work. In JavaScript, sort of the prevailing idea of the JavaScript interpreter is, I'm just going to try and do what you're telling me to do, even if it's wrong or broken, and I'll just do it. So basically, JavaScript's a lot more fault tolerant. For instance, you miss a semicolon in Java, boom, error, error, error. You miss a semicolon in JavaScript, no worries. Most of the time it'll just skip over it and keep going, and it'll say, hey, I think this is where you meant a semicolon. And in fact, one place where I always forget them is in JavaScript, they want semicolons after function declarations and other cases where you might have scope declarations like this. And so I always forget that. Well, not anymore. I'm getting a little better at it. But guess what? JavaScript's forgiving of that. It says, fine, if you forget that semicolon there, it's okay. It'll run right past it. And so what that means is with JavaScript, you have a lot more power, but sort of to quote Uncle Ben, with great power comes great responsibility. And so that is that you have the responsibility to not break your program. You can break your program a lot. And Douglas Crockford says something along the lines of JavaScript has a lot of foot guns. And what a foot gun is, it's a gun that you can shoot yourself in the foot with. And just because there's a lot of foot guns in JavaScript doesn't mean you should go shooting at your foot all the time. And so, he's got a lot of good advice on how to stop yourself from getting into trouble in JavaScript because he's a JavaScript wizard. I'm just a JavaScript guy. I just like JavaScript. So I don't know that. I probably still shoot myself with the foot gun every once in a while. But if you want to avoid, shooting yourself with the foot gun, then you have the responsibilities on you now to have good coding practices so that you don't do some of the things that JavaScript will let you do when you don't want it. Okay, and if you want to learn a lot more about that, go dive into those Douglas Crockford videos because he's got lots of great advice on good style in JavaScript. And then you might come back to my code and say, oh, gee, that is terrible style. And I'm sorry, I don't have Douglas Crockford's great style. Okay. Okay, so that was a little bit about weakly typed. Maybe there is something else that I should mention about this, which is the nature of scoping in JavaScript, where the difference between, say, a local variable and a global variable. Now, these variables that I've defined out here are all global variables because they are on the top level scope of our program. And the top level scope of the program is technically in JavaScript called the window, which is your browser window. And so if you attach variables, you're usually attaching variables to something, some kind of object or something in JavaScript, something lower down, more local. But if it's global, then it's attached to the window. Now, usually you don't want to stick a bunch of variables in your global space for the same reason you don't want to do that in other programming languages. That it causes errors when they clash and overlap. You want to have something, protecting your variables from being accessed by all kinds of different data. So there's lots of reasons why you wouldn't want to have a lot of globals. I usually restrict that down to a much narrower, limited number of globals, and then usually build all of my variables as you would into your objects and other functions that you would be using them in. But for demonstration here, I've made these global, so that's not really great style, of course. But in more recent versions of JavaScript, the older versions of JavaScript, everything was a var, and the scope of the var was the containing function. Okay, so if I went inside here, I could go and do var x equals 0 or something. This would be a local x inside this function here only, and it would not be accessible outside. And that's pretty standard. You would expect that, although there are a couple peculiarities about that. For instance, the normal scoping that you would that you would experience in Java or C++ is the scoping related to your open and closed braces, whereas the var can kind of escape that a little bit. If I declare a var, say, inside an if-then, it will attach itself to the function outside. Okay, not attach and not be local inside just that scope. But if you want that kind of local scoping inside of curly braces, I believe you can use the let. The let in the var, and let was introduced in ES6, which I believe is about 5 years old now. I'm in 2020. And so the let will give you something that is scoped more like the scoping you would expect from a C++ or JavaScript. So I find a lot of Java, or not JavaScript, sorry, Java, a lot of Java programmers will use the let instead. And then as a partner to the let is another one introduced with ESX, which is const. And you can do a const x equals 0, and as you would expect, you can't change your const afterwards. Okay, so you've got your const. Now, if you make a const object, again, you can't change the pointer, but you will be able to go in and change the object's interior components. So, you know, I think that's pretty standard in the way consts work, so you can expect constants to work the same way. Now, what that means is I'm a little bit old school. I use vars because I've been programming in JavaScript a little bit longer before ES6 came out. But if you're sort of new to it, or you really embrace the ES6 mode, then I think there's a style or standard where you use lets and consts instead of vars, and go ahead and do that. I think I've been trying to use a more ES6 style in my Mario code, so you should expect that when we get there. All right, so I think that's mostly what I want to say about variable declaration in JavaScript. And so let's get into some of the more weirder things, or again, other peculiarities of JavaScript that come along with the fact that we can go ahead and since there are no types in JavaScript, we can put all kinds of different things into, for instance, our array. Okay. Actually, I skipped over one interesting thing here, and maybe some of you noticed this line, and it looked a little bit interesting. Here, I just console.log console.log. Now, console.log itself is a function, and we can maybe see over here what the output is. This is what it gave me. Okay, it actually told me that this is a function log, and this little bit that says native code is actually it's actually just telling us that the code for the console.log function is code we can't look at. Okay, let's go ahead and try something else. This is console.log console.log. Let's do print it. So up above I wrote a function called print it, and in fact what print it does is it just prints things. So let's try it. Let's try print it. Let's call it, and let's call print it on print it. Now this is notice here I didn't do print it with something with a function call. Here I'm just saying print it the label, and print it the label is the name of this function up here. Okay, and so like other variable names, we have to be careful of our namespace. This is in the global namespace, so we don't want to overlap with any of our variables. This is a variable name here, but here I am. This first one is saying use that variable name to call this function, and let's see what happens. So I did a quick save, jump over here, reload. Oh, scroll back up here, and we can see here that now what we got here is our function print it, and we see that it's giving us exactly the code that we have in our actual code over here. Okay, now again, why is that? That's because this code was code that we actually defined as a user, and so we can actually see that when it's output out here. And the other point that I want to add to that or emphasize there is that the default state of most of the stuff in JavaScript is a string. And so this is actually a string here. The function itself is just a string. Okay, and here it's been printed out. The little blue curly F there is telling us that JavaScript knows that this string is a function. Other strings might not be, but this one is. So that's what that little F is telling us, is that JavaScript knows this one is a function. So when we output it here, when we called it with this print it label, this could have been anything, right? It could have been the array or object up above, and instead it gave us this function. Let's do a couple little more tests while we're at it. Let's change this, since we have the array above. What happens if we send it the array? Again, I'll do a quick save all, and we'll do a quick F5 reload. And that gives us, well, what we might have expected, an empty array, because that's what array was. But notice here the little arrow, that's telling us, or at least again, that JavaScript knows that this is an array. And the little arrow, we can click it usually. Oops, oh, don't look in there. That was a feature of JavaScript. And you don't want to see why. Okay, I'll tell you why that was. Well, the next thing I did is I went and I changed array down below, didn't I? And so this reference to array actually has all the stuff that I went and put in it down below as well. Okay, and that's because when it got printed out here, that again, remember this is a reference, that this reference is, at least the JavaScript reference that I have here, is a reference to the actual array, not the array at that moment in time. Okay, if I wanted to output the array at that moment in time, I might have to do it in a more deliberate, like do a deep, this sort of shallow reference to the array. I might have to deep print each element of the array one at a time to make sure that it doesn't look ahead here, basically is what it did. It looked ahead. Okay, so I said, oh no, that was cheating, it looked ahead. Let's look here. Let's look at this array here. Now this array is the one that comes as the next couple lines, these 4 lines here. I do push int, push double, push char, push string. In arrays in JavaScript are basically stacks, or the way we operate them are stacks. So we use push instead of add, but it basically does exactly what you would expect. It sticks it on the end. And then I've just done a quick print it out. So that's what comes out here under the arrays. And then again, we can maybe look in there, but oh no, don't look too far in there because I did some other stuff. That's the same bit. But let's actually look at this. The part that I want to sort of show here is we had 42, that was int. We had this double, pi, that was our second one, our char, and our string. And those, because we've called push on them, those are coming out and in index 0, 1, 2, and 3. There's some other stuff down here. Don't look at that again at the moment. Our array worked as we expected it to normally here by going through those extra, by allowing us to push those elements in one at a time. The only thing that I really want to stress here is it allowed us to push elements of different types into a list without using polymorphism or inheritance. Think about how hard it is to put a int, a double, a char, and a string inside a list, a single list in Java, and see how easy it is to do it, or how easy we just did it in JavaScript. Once again, with great power comes great responsibility. So only put a whole bunch of weird things inside a list if you know what you're doing. And so what I usually say here is you get polymorphism for free in JavaScript. So use that, but only use it when you know that that's what you're using it for. And we're going to use it in one very important place in our in the video games coming up. So keep that in mind. But for now, let's just see what other weird things, what are these weird things that I just did to the array that I said maybe are different and weird. Well, we can scroll down here and see, well, the next thing I did, and this is something that would for sure give you an error in Java, I just went and said, well, I want to make array element 42 equal to 42. Okay. And then, well, actually you can see that here, that my next array, when I output it a little bit later on, is this one here. When I output this one, look, it gets me a little bit different. It says 42, it's good, the 4 pieces that I wanted, and then it says empty times 38. So that means there's 38 empty spots. And then there's the 42. Now this is bizarre and weird, and again, please, if you're actually going to be using arrays, don't do this. This is not a good thing to do. Okay, put nulls in there if that's what you mean. Put something else in there. Don't just leave them empty. It's confusing to yourself. It's also confusing to JavaScript. Okay, JavaScript will let you do it. Like I said, it will let you do it, but it probably you don't want to do it. Okay. Now, so the other thing that I think happens as a result of this, because this is clear here, is, and maybe I'll just open this as well, is that the size of our array after that is now 43. Because we put an index 42 in there, it now thinks the size of the array is 43. Okay, again, probably not what we wanted it to do. But now when we open up the array, we can still see again 42, index 0, 1, 2, 3, and then index 42. And then what else? These other two things that I put. I put it out here that I went here and I said array, and instead of putting a number inside there, I put a string. And indeed, why can I do this? Well, remember what I said earlier. Everything kind of defaults in JavaScript to being a string. So that 42 up there kind of is being treated as a string anyways. So we can put strings inside there. And then we can do this line, which is treating the array as though it were an object. So we can do, this is sort of object notation. The line above here, this is array notation with the array index brackets, right? This is object field notation, or object trying to access a property of an object here with the dot notation, and this also works. So we can see over here in our output that yes, indeed, we have the X being filled in there as well. We have the field and we have the X. Okay, now again, can we do this? Yes. Should we do this? Probably not. Okay, we don't want to do that because it's confusing and weird. And I don't know why you would want to do it, so don't do it. If you need an array inside an object, just put an array inside an object like you would do the normal way. Don't make the object into an array as well. Okay, that's not usually what you want to do. And then likewise, if you have an array, just leave it as an array. Don't make it into an object. The only time that I will sometimes do this weird notation with array field here, sometimes I'll do this, although I still resist it. I'll often use numbers instead. Is sometimes I will do this if I'm using it's using the array kind of as a map. Okay, but if I'm going to use it like a map, a string-based map, there's maybe better ways to do that as well in JavaScript. Okay, now the reason why I got to this point, because everything here is a little bit weird, is because the reason this works is technically the array underneath actually is an object, and then objects are kind of arrays as well. Underneath the hood, they're all the same thing, which is technically a map, and that's why we can use them as a map, which in JavaScript, everything underneath is really just a map. Okay, so here we did some weird stuff with arrays. Here's another interesting line we do with an array. All this one does is define the array on the fly. And this is great for initializing things, or like I've done here, passing an array into a function if all you need to do is pass that array in and never need to use it again. So here I'm just passing it in, never need to use it again, so I'm not giving it a name or giving it a reference to use it again. That way it goes in there and then disappears afterwards when I don't need it anymore. Okay, let's continue looking now at objects. So I also had made an object up above here. Let's just make sure again. What did I do when I made that? I made that up here as a open close brace. Now remember, I told you this is not the right way to do it. We don't usually do that. I'll show you down below how to do it differently. But here we could add a field to it, an X to it, an int to it. We could add a whole bunch of different stuff in as fields. Here is where we're not treating it as an object anymore. Here we're saying, okay, treat it as a array. Don't do this. This is probably bad. But adding an array in as a field of your object, that's perfectly fine. Okay. Adding a function on, this is not the right way to add a function onto your object either. So don't do it. Okay. I'm just showing you can do these things. Again, showing you the power so that you stop yourself and say, don't do that. Okay, I'm going to stop myself. If we do output this object, let's go see what the object looks like. Because we put the 10 in there, that's the weird one. Okay, let's maybe ignore that. Otherwise, it's an object. The curly brace tells us an object, but the arrow here tells us, just like up above, the array and the object are treated the same by JavaScript. Under the hood, it thinks they're the same. And so we can still open it up and look inside. Now, the only difference is it put this one in square braces and this one in curly braces because we told it that we intended it to be different. We told it when we initialized it we wanted array to be an array and we wanted object to be an object. And so since we told JavaScript that we wanted it to be different things, it's treating it as different things, even though, again, under the hood, it is going to be the same thing. Now, here, all the elements that we expect to be are in here. The other thing that's in here that's weird is this prototype, and usually we don't look at it, but the prototype is where you're going to find the methods attached, usually, okay? Now, these are all methods that you inherit from just a normal object inside JavaScript, just like you have a normal object inside Java as well. Okay, now this next line here was generated by this line here, which was just like we console.logged an object that we did, or sorry, an array that we defined on the fly. We can define objects on the fly, and this is a more common way of defining objects, but still not necessarily the right way to define objects. I say not necessarily. I define objects this way when I will need them, as it says here, on the fly. Okay, by on the fly, I mean just like that array up above, I need the object for 1 second, that is to maybe to send it as a parameter into a function call, and then it disappears. I don't need it anymore, so I don't need to give it a name or a reference. I just define it on the fly like this, and the syntax is simple JSON syntax. If you're familiar with JSON syntax, it's called JavaScript object notation, which is open curly brace, then the name of the field, then a colon, and then whatever that value is. In this case, I made it a string, and then we separate those with comma. So we do another field property and its value as well, as continues on here. And we can see that when we output it over here, that indeed we got, where are we here? This one, we have to message and property, the two values that we expect inside that object. Now, when do I often define an object on the fly? I'd say the most common case I might do it is say I need a point and space like an XY, and I just need to bundle it. Or also say I'm returning two things like an XY, and I just need to bundle it. And so I maybe don't need to give it a name, so I just, right in the return call, I will have a object defined on the fly, something like this. Okay, now again, why is this helpful and useful? Well, think how hard it is to return two things from a function in a simple Java function. In JavaScript, you can return however many things as you want by just throwing them all into one quickly defined object on the fly. So again, a lot of the things I'm showing you here are tricks that maybe we don't want to use all the time because they might be a little bit problematic or cause us to get into trouble. But we can use them if we know what we're doing when we're doing them. Okay. All right. What else do I have here? The next thing I have here is a class. Now this class is following ES6. Now I am old school, so ES6 is new to me, even though it's not that new, because I've been very comfortably operating in an older version of JavaScript for over a decade. So I'm slowly as a tortoise adjusting myself to ES6, and ES6 introduced this new class syntax. And I'll be honest, the reason they introduced it was because Java people were confused by how classes worked in JavaScript, and there was enough Java people out there that they influenced JavaScript creators to put the class keyword in there, even though, and I promise this 100%, the class keyword does nothing in JavaScript. It is just a alias for the function keyword, but it helps you organize your code a little bit better, so that again maybe non-JavaScript programmers can read your code and say, oh, this is a class. And so they also introduced this constructor keyword and the constructor or syntax. I'm still not super familiar with it, so I still screw it up every once in a while. But we've got it correct here. This is sort of an older way of doing things that you would do in JavaScript, but they've introduced a new way that I am trying to adopt myself. Say you have a bunch of parameters in your constructor usually that you want to assign as local variables to your object. So you use the this operator as you would expect. This refers to in the local scope to the current class, although I have to be very careful here. It actually is going to usually refer to the local function. This refers to the local function unless that function is attached to the class. Now this constructor is attached to the class. This function getOlder is attached to the class. So within the scope of those, it refers to the class. But if you use the this operator not within a class, just within a function, this will refer to that function, which is a little bit strange. And we'll see how that comes into play maybe here or there. Again, when it comes into play, I will usually point these things out to make sure. Now, the other thing, this is how I usually do my my initialization in ES6, which I'm not sure if this is an ES6 adaptation or if it's just me adapting to ES6 that I've added this as well. Often you might have this really long list of things like, you know, this.name, age, address, phone number, blah, blah, blah. Maybe you got 20 different things you want to assign here. Instead of having 20 lines in a row, I'm using a couple different things here. First of all, object.assign will assign to whatever object you pass in this case, this object, the person, all of the fields that you have put inside this object here. Now notice, this syntax I could do is this, name, age. What that would do is it would say, make a field called name, and then take the parameter that was passed in called name and give it that value. Same thing here, age. But again, with some simple shorthand syntax that's, this I think is ES6 at least, you can now on the fly define an object like this by just putting the name of the variable in there. It will name the field the same as the name of the variable. Convenient, lucky, nice. All it does is it takes maybe a real long, nasty bunch of lines that you would have to put into your constructor, and it allows you to do it all on one line. So maybe I'll just comment these ones out instead, and that allows me to do it all at once. Okay. Now down here, I create a local variable. I called it int. I could do let here if I wanted to as well. Why did I do that? Maybe you can see out here, when my object was created, when the constructor was called, this local variable was output, and its value was 1337, which was different than the int value of 42 that we had up above. So that's just showing how, you know, local variables still work the way you expect them to work. Okay, so this class I created creates a person, creates a name and age fields attached to that person, and then I just made one simple function other than the constructor called getOlder, which just pluses your age. Okay, so let's just see how it works. Again, a lot of this syntax is made to look like Java so that, or C, so that you can, if you're comfortable and familiar with that, you'll be comfortable and familiar with that. Even though it's different under the hood. Here we have, I'm just creating two variables, Alice and Bob. Again, I could use let here instead, or const. The only difference with using a const is I would not be able to do something like Alice equals Bob or Bob equals Alice. I would still be able to do Alice.getOlder. Okay. In this case, what I did is I called Alice, made her 33. I called it with Bob, made him 43. I said get older, Alice, but I didn't say get older to Bob. And then I tried to output them, and when I output them, this is what I get. I got a person, which again we saw up above. Now notice, this is different than the ones we had above. These ones had no names out front. That's because these ones had they weren't of a type. They weren't of an object of a type. This is an object that is of type person. So it tells us, again, this is JavaScript telling us, hey, I know this is a person, even though, you know, it will factor in if we start doing a call of, or we do a call of the function called instance of. Actually, I don't think it's a function, it's an operator. But if you use the instance of operator, it will go and check this field and say, hey, is it a person? And in this case, it is. And again, it's told us if you do, maybe I'll just point this out as well. If you take an object and you output it here, just the object by itself, then it will give you this format where it will try and put the object, it'll try and write out its string format, but it'll give you the little triangle so you can open it and look inside. Whereas, you can see up above here, when it tries to make the string format, sometimes it's too long and it does a dot, dot, dot there. It'll get to a point where it just says, okay, there's too much space in there. Also, if instead of outputting it as just the object here, you output it as Alice plus something like a string, you say like, you know, Alice and then plus this value, it will convert it all to a string and it will no longer give you the ability to click on the little triangle and look inside of it. So usually you do, when you're doing this for debugging purposes, usually you want to look inside that thing. So I usually just want to remind you here, make sure you just put it all by itself in that console.log. If you need to label it, just put the label on a line above, and that way it won't ruin it, and that way you'll know. But usually, luckily, if you do it, it will tell you what it is. It tells you it's a person, so that's good. And the only thing we need to double check here, yes, indeed, Alice is 34, Bob is 43. So Alice, the get older worked on Alice, I guess is all that matters there. Okay, what about these last two? The last two have to do with the asynchronous nature of JavaScript. I already mentioned that when I talked about downloading images, but here I want to talk about asynchronous nature within JavaScript. Now there's two things that we'll have to do. One is we might fire off something that we don't want it to happen right away. We might want it to delay, or we want it to happen periodically. Every second we want it to do something. And these are common things we might want to set up. Or the other thing that might happen is, because we might set up things that happen asynchronously, like downloads or database accesses, or like I'm going to show you here in a second, we might need to respond to those things in an interesting way as well. And we usually respond to those things by setting a listener. I don't have an example of a listener here, but that's my next video. We're going to look at some listeners. So by setting a listener, what it does is it's just waiting for something to happen, like the download to finish. And when that happens, it responds by doing something else. And what that something else is usually calling a function. So I want to point out here and this is sort of maybe new to us as JavaScript. The very first thing is, I'll point out a few things. Window, remember I mentioned window is the top level object that everything is attached to, okay? It refers to your browser. So here this is reserved. When I use window here, I haven't defined what window is. It's already defined for me to be a reference to that highest level object. And luckily, connected to that highest level object, you can go take a look at this if you want. Say, take a look at it on the Mozilla Developer Network. That's where I recommend to go look up. If you're a Java programmer and you usually go to Oracle to look up, your API, then in JavaScript, you should go to the Mozilla Developer Network. Don't go to whatever it is, W3 Schools. W3 Schools is a horrible place. It's got false information on there, and it's not updated enough, and it pays Google to be put at the top of the search results. So skip over W3 Schools and go down to the next one and go to the Mozilla Developer Network. That's where you want to go. And if you want, you can go there and you can go look up window, and it will tell you all these cool functions that you have that are attached to window. But the one I wanted to point out here is this function called set timeout. What that does is, if you want to call a function but you don't want to call it right now, you want to delay, you want to wait a little bit and then do it. And there's some reasons why you'll want to do this. And I'm going to show you in game programming, this might not be the best way to do it. There might be better ways to do it, but you might want to do this here and there. And in this one, I just said, in this case, I want to output this line 1 second delay in 1 second, or 1,000 milliseconds. Okay, so the way that this works, the way that set timeout works, is it takes a function as its first argument. Okay, it's a function. Now this function here is like the function we defined above, but I'm not giving it a name. Above I gave mine a name called printIt, so I could call it, right? This one I'm not giving it a name. I don't need to give it a name. because set timeout knows that when it's time, this is the function it's going to call. I could give it a name if I want, okay, but I'm not going to give it a name, all right? Then this is a function that's defined on the fly, just like we defined the array or the class on the fly up above. Here I'm defining this function on the fly. Now when you define it on the fly, that doesn't mean you're calling it on the fly. Okay, you're just defining it on the fly. You can also define a function on the fly and then call it on the fly. That's weird. I'll show you one example of that probably coming up, but that's very strange and not very often do we do that. But more commonly, we define a function on the fly just like we did above when we want to pass it as an argument into another function. And that is not as common in other programming like Java and C++, but it gets more common in JavaScript for a couple of reasons. One, because JavaScript is at its core more of a functionally programming language, meaning you pass functions into functions is more of a base or natural thing to do. And then secondly, because web programming is naturally asynchronous, we don't really know when things are going to happen, we need to have this ability to respond, listen, wait for something to happen, and then call a function when that final event actually occurs. And so to do that, we set up listeners, and listeners usually take functions as arguments. We pass functions in. So here, we're defining the function on the fly and passing it in. Now, keep in mind, we don't have to define this function on the fly. We could have passed in here print it, for instance, if we wanted to, because that function was already defined for us. But commonly when we do this, we will define the function right as we're using it, because we don't need to use this function at any other time. We only need to use it here as an argument to set timeout. Now once we've got a function, this function you can see is pretty easy. It just console.logs this. And after we have the function, the second argument for set timeout is the delay. How long do you want to delay in milliseconds? So in this case, it's 1,000 milliseconds is 1 second. So I did a 1 millisecond delay as well. And then let's just go back to our output here. I'm going to do a quick reload and let's watch. And we'll do it one more time just so you can see the 1 millisecond delay happened right away. The 1 second delay took 1 second. Okay, it takes 1 second. Okay, and so in very old game programming, you would set this up to do your frame rate of 60 frames per second. You would set up your updates to do this. Now we're going to have a more clever way of doing that than that. Modern browsers are smart enough to tell us when it's our turn to go again, and we're going to do that. But this is sort of an old way to do it, and this is just a way to at least get us thinking, hey, web programming is asynchronous. And so we have to deal with asynchronous things. And the worst thing that happens is when an asynchronous bug shows up, where something is going wrong, we think it should be happening right, but something didn't load yet, and so something isn't defined yet, and we don't know why, and it's some kind of asynchronous error. All right, that was my rapid fire quick introduction to JavaScript and some of the interesting cool things in JavaScript. If you are a Java programmer, there's a lot more to JavaScript, so I do encourage you, go take a look at some of the Douglas Crockford videos that I've mentioned. I'll put the links down below, and also if you need to, explore ES6 in a little bit more detail. ES6 has a lot of cool, fun little operators options that I didn't have time to talk about in this video, so take a chance to take a look at that. In the next video, I'm going to jump right into how some of my base code works for my game, and I'm going to encourage all of you to download that base code to use for your own games. So getting to know how it works is going to be critical. So that next video, we'll talk about Asset Manager. So thanks a lot for watching, and we'll see you in the next video.